I'm going to review some vocab you guys would have done in geometry a few years ago. But ultimately, the goal of this lesson is to make sure you know how to convert angles between the two different measurements we're going to use, degrees and radians. And then ultimately, the last part of the lesson is to make sure you know how to find coterminal angles to any angle. All right, so let's start with the first one. So we have a ray is a directed line segment, as you can see with this image to the left. And that first point of the ray is always called the endpoint. Okay? And then we have an angle, which is what we care about in this lesson, is the union of two rays having a common endpoint. And we call this common endpoint the vertex. Okay? Now, we have lots of different ways that we can denote that we're talking about an angle. The most common that we'll use are theta and alpha. I really reserve the use of alpha for something specific called a reference angle, which I'll actually mention later on in this lesson, but really won't get to kind of the importance of it till later. But theta is probably the most common one, so I will probably use theta. All right, now let's talk about standard position. Okay, so the measure of an angle is the amount of rotation from the initial side to the terminal side. So that's essentially where it stops. Okay, and the most familiar unit of angle measurement is the degree, which we will absolutely be using degrees as well as radians. We'll get to in a moment. All right, 1 degree is 1/360th of a circular rotation. So the entire way around is going to be 360 degrees. Okay. So always kind of the main thing you need to know is that if you're using degrees, you must have that degree symbol. If I don't see a degree symbol, then I'm going to assume you're talking about radians. Okay. An angle is in standard position if its vertex is located at the origin. So kind of looking here, here's the origin. All right, and the initial side is on the x-axis. And then in this case, this one is moving counterclockwise to get to the terminal side. So that is said to be a positive angle. So positive angles will move counterclockwise. And if you're moving clockwise, then the angle is negative. And again, we'll get into a lot of this stuff over the next few weeks. Okay, let's talk a little bit about quadrantals. All right, quadrantal angles are a special case because their terminal sides lie on an axis. So like if you look at this first one here, right, the initial and the terminal side is actually both the same, the x-axis, so that's 0 degrees or 0 radians. If you move, and you remember from a 90-degree angle, right, if I move from the x-axis to that positive y-axis, all right, so that quarter of a rotation, that would give me 90 degrees. So that is another example of a quadrantal. So 180 degrees, we have 270 degrees, and then all the way around is 360 degrees. Okay, let's get into what a radian is. All right, now a radian is the measure of a central angle of a circle that intercepts an arc equal in length to the radius of that circle. All right, now it gets into a little bit here about using that idea of circumference of a circle. If you remember, circumference is 2 times pi times the radius, but I'm not that worried about it. All right, ultimately, at the end of the day, I just want you to know how to convert between degrees and radians. All right, so because the total circumference equals 2 pi times the radius, a full circular rotation is 2 pi radians. So understanding that 360 degrees is one rotation, that's the same as 2 pi radians. So you're going to go ahead and memorize that. We'll be using that relationship later on in this lesson. Okay, if half of the way around is 180 degrees, well, half of 2 pi is pi radians. So that's the next one. And then a quarter turn is 90 degrees. So if we divide by half again, that gives us pi over 2 radians. And we'll be using all of this understanding to label all of the circle all the way around. I put this last one here to show you that if you did one more, divide by 2, so even smaller, 45 degrees is the same as pi over 4 radians. And you'll get to a place in this class with this concept of trigonometry where you'll have all of this memorized. Okay, so let's go ahead and get into kind of showing you all of these angles in degrees, and then I'm going to write down their measures in radians. So I like to start with the quadrantals. All right, 0 degrees is 0 radians. All right, 90 degrees, as we just mentioned, is pi over 2 radians. 180 degrees is pi radians. And 270 degrees is 3 pi over 2 radians. If you go all the way around, remember that's 360 degrees or 2 pi radians. Okay? Now, in terms of my next ones, the ones I'll do next are with the 30 degrees. All right? 30 degrees is the same as pi over 6 radians. All right? So if I were to go another pi over 6 to get to 60 degrees, that would be 2 pi over 6 radians. We don't actually write 2 pi over 6 because we can reduce 2 over 6 to be 1/3. So we actually write pi over 3 radians. All right, so with that same understanding, if I go from pi over 2 to 120 degrees or 90 degrees from 120 degrees, right, I'm going to be adding another pi over 6 radians. So that's going to be 4 pi over 6, but we don't write that. We write 2 pi over 3 for 120. And then for 150, all right, we write 5 pi over 6. And don't worry, I'll show you guys the way that I kind of memorize this or how I figure it out if I don't have it memorized. All right, keep going. All right, if I go one 30-degree move or pi over 6 move past 180, that's going to be 7 pi over 6. All right, then this is going to be down here 8 pi over 6, but we reduce that to 4 pi over 3. All right, then this one is going to be 5 pi over 3. And then finally, that 330 degrees is going to be 11 pi over 6. Okay, now let's talk about the ones that have a denominator. They're going to have a denominator of 4, so I'll use a different color there. So in this case, 45 degrees is the same as pi over 4 radians, like we talked about earlier in the lesson. All right, so the way I think of it is that's 1 pi over 4. Do another 45 degrees to get to 90 degrees. That's 2 pi over 4, which we reduce. Then 3 pi over 4 takes us to 135 degrees. 4 pi over 4 reduces to pi. 5 pi over 4. And then 6 pi over 4 reduces to 3 pi over 2. And finally, 7 pi over 4. So that's kind of the way that I do this. And I think that's probably the most helpful in terms of figuring all this out. Okay. But you're going to see we're going to use a lot of this, really not in this lesson, more in later lessons. Okay. Let's get to kind of one of the main things I wanted to do, which is converting between radians and degrees. All right. And really the way I think of it is whatever direction you're moving, the relationship that you are going to look at is either going to be 180 degrees over pi or pi over 180 degrees. Now you could use, if you wanted to, you could use 2 pi and 360 degrees, but we're just reducing it already. So I'm either going to use this one or this one. It just depends on the direction that I'm moving from degrees to radians or radians to degrees. And if you have trouble remembering it, just think about what are you trying to cross out. So I'll give you an example. In this first one, going from radians to degrees, I'm trying to cross out the pi. I want to end up in degrees. So if I'm trying to cross out the pi, I need the pi to be diagonally from my original pi so I can cross out that pi. So you put 180 degrees on top. All right. So when you do that, the pi's cross out. 180 divided by 6 is going to be 30 degrees. Now you already knew that one from earlier in the lesson. Now this one is interesting. This is radians. It doesn't have a degree unit. So this is 3 radians. Most of our radians, not all, but most of our radian measures will have pi with it to make it obvious you're talking about radians. But in this case, it's not obvious. So we do need to put the pi in the bottom and 180 degrees on top. All right, so this one is a little tricky. So I'm going to multiply straight across because nothing cancels. And I get 540 degrees over pi. All right, so I'm going to actually use my calculator now. All right, so I'll go to Desmos here. And we can actually write this rounded to the nearest degree. All right, so 540 degrees divided by pi. Let's go ahead and actually use the symbol for pi. So we have 540 over, type in pi, to get 172 degrees when you round to the nearest degree. So this is approximately 172 degrees. All right, let's try one more. This one does have my pi, so it makes it pretty, or at least a little simpler to see. I want my pi in the denominator so I can cross out. I do notice a negative sign here. All right, that would make it look different if I were to sketch it. Remember, you move clockwise for negative angles. For this one, though, it doesn't really matter because I just know my answer is going to be negative. So I have a negative, and then let's see if we can reduce this. 180 degrees, or 180 divided by 4. Looks like that's going to be 4 goes in 18 4 times. So 45. And then times 3, 45 times 3. Let's see, that's going to be 135. If you're having trouble doing this mentally, remember, you don't need to do it mentally. Just make sure that when you go into Desmos, what I tell students on this is there's no reason to type in the pi's because you already know they're going to cross out. So I'm just going to type in negative 3/4 times 180. So I'm going to type in negative 3/4, there we go, times 180. And there you go. You see negative 135. So that's it for converting from radians to degrees. Now we're going to go the other direction and go from from degrees to radians. I'm not a big fan of the DEG. So really I'm thinking 15 degrees. So 15 degrees over 1 times, and I want to cross out degrees. So I'm putting 180 degrees in the bottom. All right. Now, when I do this, all right, you could go ahead and try to reduce on your own. You can see that you can reduce 15 over 180, but go ahead and use the calculator. You have it at your disposal. So 15 divided by 180, if you type in 15 over 180, and if you look this symbol here, if you click it, it will give it to you as a reduced fraction, so 1/12. Just make sure when you do this, for your IXL or for the test, that when you do this, you don't just write 1/12. This one is going to be pi over 12. So make sure that you have that pi in the answer. Same idea here. 126 degrees over 1 times pi over 180 degrees. I'm going to go to my calculator and type in 126 over 180 and see what that reduces to. All right, so 126 over 180, that reduces to 7/10. So 7 pi over 10. Don't forget to include that pi in the answer. So 7 pi over 10. And then finally, one more. We have negative 75 degrees. Remember, all that means is that my answer is going to be negative. All right, key thing is I'll just do a quick little sketch here. All right, if you were to sketch negative 75, you would start at your original x-axis, but you're going to move this way to negative 75 degrees. All right, so you just move clockwise. That's the only difference. Okay, so let's put it over 1 times pi over 180 degrees. Again, you can type in the negative if you want. You don't have to. I'm not going to. I know that the answer will be negative. I'm just going to type in 75 over 180. All right, so 75 over 180, which reduces to, when I click the button, 5/12. So my answer is negative. Don't forget the negative in the answer. Negative 5 pi over 12. All right, and that's the process for converting in both directions. All right. All right, let's move to coterminal angles. This is the last thing I want to make sure we talk about in this lesson before we move forward. So if we have two angles in standard position and they have the same terminal side, they are called coterminal angles. All right, and the way you find coterminal angles is that you just do one full revolution, whether that's in a positive direction or in a negative direction. So counterclockwise for positive, clockwise for negative. All right, and you just add or subtract 360 degrees. Or if you're talking about radians, you're going to add or subtract 2 pi radians. Okay, so that's kind of the difference when you have different units. Okay. Now, this last thing before we get into coterminal is briefly mentioning something called a reference angle. All right, so I'm gonna reference it here, no pun intended. But really, when we get into later lessons on how to evaluate some trig functions, I think that's where I'm going to need you to know what a reference angle is. But I'm going to introduce it here and really hit it hard, later on in another lesson. So it is the measure of the smallest positive and acute, remember acute just means between 0 and 90 degrees, angle that is formed by the terminal side of your angle and the horizontal axis. Or what I tell students is always thinking about the distance from your terminal side to the nearest x-axis. All right, so quadrant 1 is the simplest one. Quadrant 1, if your terminal side ends up in quadrant 1, it is always going to be that distance from the x-axis to that terminal side, and it will just be the reference angle. So like if your angle is 45 degrees, the reference angle for 45 degrees is also 45 degrees. Quadrant 2, you're going to find the difference between the nearest horizontal axis, which would be 180 degrees, minus that terminal side. If it's in quadrant 3, it'll be 180 degrees, going the other direction. So you're actually going to take the angle and subtract 180. All right, and then finally in quadrant 4, the nearest x-axis is all the way around. So you're going to have 360 degrees minus that angle. All right, so again, I will really, really, really hit this hard in another lesson. Okay, so let's find coterminal angles. We'll first do it with degrees, and next we'll do it with radians. So in this first example, it says to find an angle that is coterminal with an angle measuring 870 degrees. So it wants our angle to be between 0 degrees and 360 degrees. So what I notice is 870 needs to get smaller. So I'm going to subtract, remember, all the way around is 360. So start with 870 minus 360, and that's going to give me 510 degrees. All right, when I look, this is an answer. All right, but is that answer between 0 and 360 degrees? The answer is no. So even though this is coterminal, it's not one that I want. So I have to do another subtraction of a full rotation, so minus 360 to give me 150 degrees. And is that between 0 and 360 degrees? And yes, it is. But I want to make sure you know that even though 150 is technically the answer, 150, 510, and 870 are all coterminal. They would end up in the exact same spot. All right? Let's do the same thing with negative 300 degrees. I notice that negative 300 degrees to get between 0 and 360 needs to actually go up or increase. So I'm going to add negative 300 degrees plus 360 degrees, which gives me 60 degrees. Is that in between 0 and 360 degrees? The answer is yes. So I am done. The answer is 60 degrees. Let's do the same thing with radians. Guys, it's the exact same process. Instead of using 360 degrees, you're just going to use 2 pi radians. So when I look at 19 pi over 4, right, even if I just kind of ballpark this, 4 goes into 19 almost 5 times, right, just very close, just shy of 5 times. So that's just shy of 5 pi. So this is too high. I need to subtract. I need this to be smaller. So I'm going to subtract 2 pi. Okay? And when I do that, I'm going to need to get a common denominator. So I'm actually going to write this as 19 pi over 4 minus, and my common denominator of 4 is going to make this 8 pi over 4. Remember from your days of middle school, you multiply the top and the bottom by that same number of 4. So now when I subtract, I get 11 pi over 4, which is still too high, right? 2 pi is the same as 8 pi over 4. So I got to subtract another 2 pi, which this time I just wrote as 8 pi over 4. And that's going to give me 3 pi over 4. So this angle of 3 pi over 4 is what I'm looking for in terms of coterminal between 0 and 2 pi. All right, let's do one more. This time I have a negative. I got to get it to be a positive, so I'm going to be adding this time. So negative 17 pi over 6 plus 2 pi. But again, I need to get a common denominator. This time my common denominator is not 4. It's actually going to be 6. So I need to multiply 2 pi times 6 to give me 12 pi. When I do that, I get negative 5 pi over 6, which is still not there, right? I'm looking for a positive. So plus 12 pi over 6, which is going to give me 7 pi over 6, which actually that one is between 0 and 2 pi. All right, so again, the main takeaways here are looking at finding how to go from degrees to radians and radians to degrees, so converting, and then finding coterminal angles. So make sure to try some of these practice problems. Good luck.